recording purpose. My name is A. Ishan Rao. I am a PhD student from Indian Institute of Technology, Tirupati, IIT Tirupati. Now, let's start with maybe from you people. What is your expectation of the course? And then I may tell you what exactly this course is all about with respect to from the academic point of view, and what is your expectation, so that we can set off certain baseline and I can plan better for the future sessions. Okay, so anyone can unmute themselves or they can type in the chat section about what you expect from this deep learning course. So anyone can unmute, otherwise you can type it out in the chat box. Okay. Uh, okay, so let's wait by the time these someone will typing out, since most of you are not unmuting. Uh, Let me check the host control also. You can turn off your microphone. Okay, so you can turn off your microphone so you can tell also. Okay, fine. So let's stick to the coming back to the topic. This deep learning, understanding of deep learning, knowledge of AI. Okay, that's perfectly fine. So one thing I will start with telling you this: most of the course will be a kind of mathematic intensive. That being said, that the purpose of this whole deep learning course would be why a machine learn the way it is learning right now. So it will tell the actually the concepts behind the what mathematics has been involved right now to get to a stage where machine is learning certain aspect. So what are the learning algorithms, what are the data you're using? So it will be mostly background. Obviously there will be certain co- uh, code and practical aspects also, where you will try to codify a basic neural network or a machine learning classifier, or in this case a convolutional neural network or recurrent neural network, or maybe a LSTM, long short term. So these are multiple terminologies are there, so which you can do. So again, setting the context in this place, it will be mathematical intensive. So there are few things that you should be keep knowing, that we'll discuss today. What are the things that you might be knowing uh, for starting up this course or have the expectation for the next 3-4 months. That being said, another thing that you should understand, that why mathematical intuition is necessary. The reason being, now you will get so many libraries, so many products, where you can directly plug and play a machine learning or deep learning model. Okay, so even a person who might not know any deep learning model, they might uh, just say that, okay, I will use this library, I will use this function and let the machine decide, learn on its own, right? But that's a naive approach as of now, because it is reached to a stage where it is there with common people. Now if you are coming from the perspective of understanding AI or deep learning or any other things, you should go above that, this thing, that why a library is working the way, why a classification learning the way it's learning right now. So what is happening in the background, what is the algorithm behind it, right? I can tell you for sure that machine learning algorithm are being used by physics, chemistry, mechanical, civil, everyone. Like, it's not only CS people, everyone is using it. But most of the people are using it from as a user perspective, just like how we use phone. We don't know how actually use phone is working, but we know how to use the phone as a user interface. Similarly, every department or every field is using like that. So it's a good opportunity for you to, along with learning the practical aspect, which mostly I will be covering throughout this interaction session. You should have a mathematical intuition, like how actually in the background it's happening. Okay, so that being set as a context, let me share the screen and we will discuss few of the points with respect to the machine learning, as it's where in a whole machine learning process, deep learning is a part of machine learning is a part of AI, right? I think that if that is being clear, where human comes into picture and where machine comes into picture, why it is called actually machine learning. So we will discuss with that and few of the components which you might be needed over the period of this course. Okay, so let me share the screen from my second device. Share screen. And if you have any question, doubts, please put that in the chat box so that I can uh, see from time to time. Okay, so we will talk about something called expert systems, and there's something of 6 jars, or the basic 6 elements of machine learning to start off with. I am not touching perceptron mm, or the neurons and all those stuff, because that we will start from the next thing, because if you have seen the week 2 or week 3 lecture, by this time you have seen that the mathematical intuitions and all this already started, algorithms have already been started. So we'll discuss all the stuff slowly, and we'll build on that, how to code it, what platform you can use as a start of it. If you don't know how to code a deep learning model, we will try to touch all these aspects within this. So another thing I want to make sure to all of you who might be coming again in the next few sessions, that I'm mostly will taking the basic step-by-step approach. I'm assuming that you might not know much. You might be starting from basics. So that's what. So I will, when I will coding, I will do basic simple codes. I will build simple use data sets and all that. So that's the context I want to set it. Okay. So to start with machine learning, or per se AI, what we expected that machine should learn from whatever we are providing and should give us some output, so certain kind of output, right? Now, before doing that itself, let's discuss about something called as expert system. And before that also, let's talk about uh, how do, okay, let me, okay, how do human makes decision? That's a basic question which mostly many people start off with, right? How do human makes decision? That's how we'll start, because what we're trying to emulate is us in through the machine, through some mathematics, through some way, by asking this question, that how do we make a decision, right? So let's take an example for that. So let's suppose you're going to a doctor, okay, and you have certain symptoms of certain uh, uh, certain disease that you might be having. Suppose you have cold, you have high temperature, you are vomiting, you have rashes, something like that. Okay, now the task of the doctor is to identify what has happened to you, right? So what it will do, basically, it will ask multiple questions, try to identify, okay, these are the common things that I'm finding with the within the with respect to a person, basically me. So I'm considering it's a rainy season right now, so one prominent question I may ask is it a dengue or not? Okay, so it's become a decision problem, right? So when you're going to doctor to diagnose what is the disease you are having, so you start with of telling symptoms, and the role of the doctor is to diagnose, tell that whether I have particular disease or not. So it comes down to a decision problem. We call this a decision problem, right? Now, if you again retrace back and try to see how human make decision, it needs certain inputs. Now, inputs are basically the symptoms that I'm telling to the doctor, that these are my symptoms. Now, the next part will be the doctor is weighing those symptoms. That is it having high temperature, or I am having too much cold, for how many days I am having cold, why I'm not, if I'm vomiting, for what kind of food I'm vomiting, what I had earlier. So I just can't just say that, okay, these are the symptoms, and I can just tell, okay, they're dengue or not. You will try to understand the history about it. So what is happening here, once you try to understand this, doctor may have other patients as well, like let's say patient 2, patient 3, and all that, patient 3, patient n, so on. So what we call as experience, what the doctor will say that, okay, in majority of the patient, when I found that there's a dengue, I found that cold should be at certain temperature. This a high temperature would be a certain point, that is 101 Fahrenheit or something more like that. Vomiting should be continuous for 2-3 days. Rashes should be more prominent. Just giving example with respect to that. So once you have this, doctor make a decision that, okay, it might be possibility of a dengue. I might have a dengue. Now doctor has done that. Now what we can make something, so what we can understand from this problem, to make a decision, the doctor should have some past experience. Okay, I might have some past experience. A doctor should have past experience. Second, I should have multiple inputs from the user. So doctor should have multiple input from its patient. So what it will be? That means I should have multiple combination of inputs. I should have some permutation, some combinations with respect to that, which might lead to me to tell that it is a dengue, or doctor say that it's a dengue. Okay, that's a one thing. So these two things helps the human to make decision. Now, how we can say the same thing for a machine, right? So what we can do is we can say in a simplistic way that I have a machine. Uh, so let's say it has to identify whether dengue or not. Okay. So I have 4 input features right now. So let's say it's a rashes, whether it's have a cold or not, and vomiting, and high temperature. So these are my 4 inputs. These are my inputs. Okay. Now I will tick off certain things. So if I have a rashes, okay. I might have cold, no. I have vomiting, yes. I have a high temperature, yes. Now I have 3 inputs right now. The machine, so machine, how the machine will understand if I want to trace it back to the machine, tell that okay, I have this input, following inputs are there, and some of the inputs are not there, and from that I want an output which is whether it's dengue or not. For the simplistic way, we can say that okay, let's assign rashes as 1 and 0. Okay, if I have rashes, then it's 1. If it's not, then 0. Same for cold, same for vomiting, and same for high temperature. Now once I get this, I will tell as output as 1 and 0. So what is happening? I converted my problem to a numerical, to to play with as a number. So I made it as a numerical problem. Okay, so I converted the whole thing into a numerical problem where inputs in this case will turn me as a feature. Okay, now I have certain features. From this feature I will try to understand whether I have a output or not. Okay, so for this simplistic case we are making it as a 1 and 0, as a boolean. That means either I have, either I don't have. There's no in between right now I'm talking, but that's for simplistic case. Okay, now once I make this problem, I can feed it to the machine and machine can make it understandable. Now only one input might not be sufficient. It might need thousands or hundreds of other old data where I am having a table where I'm taking rashes, cold, vomiting, other input features. I'm getting as output as dengue or not. So I have this. So now the machine task will be to learn from it, right? That is way what we told as machine learning. But earlier it is not like that. What earlier it used to say, earlier it used to happen that what a decision making will be like if I have rashes and if you know, if you have done coding, then it's like and it should be 1 1, and vomiting, and high temperature, then it has a dengue, else it's not dengue. Okay, so I converted right now. Before telling about all this stuff, I just made it a simple if and else statement. Okay, where I'm combining few input features. Now the input features can be many, like I can include rash, cold, and high temperature, cold, vomiting, high temperature. The combination will be many, but you get the gist, right? So I will create a if else kind of problem, right? So this kind of when a problem is there and you want to tell whether the certain thing is not whether I have a dengue or not, or whether I want to go to movie or not, I will try to create it as a if and else problem, as a conditional problem. Okay, so this thing, when you give it to a machine, codify as a machine, it will become an expert system. Okay, now what expert system in generally tell us is I have a knowledge base. So for example, earlier the dengue is like I'm a doctor. I'm not only diagnosing you as a first patient. I might have 1,000 patients earlier. So I have keep on all the record data with me, right? So I will have a knowledge base with me. Now since I am a doctor, I will analyze and I will create certain kind of rules. I will create certain kind of rules here. Okay, now rules are like if and else statement. In this case, if this is there, then this, else if some other condition, then this, else this condition, some output we are giving. Okay, and right now we are talking within the context of 1 and 0 only. Okay, that means it's a classification kind of thing, either a certain output is there or not. Okay, so that is, I'm creating a rules for that, but for that I need an expert. Like since I'm a doctor, I have experience, I have practiced a lot, that's why I can make a rules engine. Then as a suppose now you are a new person and you don't want to go to doctor, you just want to ask the machine that whether I have a dengue or not. So what you will say, okay, I have this symptoms. So you will click on certain symptoms. Okay, I have this symptom, and what the machine will do, machine will again go to use a rules engine, will check. Okay, these are symptoms there. Whether I can find some output from that one, whether that kind of rule present or not. If that rule is present, then machine will advise that okay, you might have a dengue, I might not have a dengue. Okay, this kind of systems is mostly used in 1960s and 70s and 80s, kind of like that, when the computer has been started coming to the market. Okay, so it's mostly like you are outsourcing your decision making to a machine. That's what you are trying to do with the expert system. So suppose right now you have seen the Chandrayaan 3, right? Now Chandrayaan 3 will have certain tests, but it will have thousands of tests, right? So humans can't do thousands of tests, but what they might have done, that they have selected, okay, they started a process where they say, okay, we check this system, okay, this system is correct, this system correct, okay, other system n is not correct, so come back, retrace back to system n minus 1, check other condition, if that is there, again check the system n again. So multiple if and else conditions will be there, and based on that you try to tell to a human whether the system, the overall spaceship control in this case, the Chandrayaan thing is correct or not. Okay, so that this is what deals with the expert system, and people have used it in organic chemistry a lot, spaceship, or you might, most of the people might know, it's like bank loans. Okay, so to give loans, they will not just, why they ask for so many stuff, they might ask for a PAN card, your IT returns, your pay slip, your other loans, past loan, how you're paying the credit history, or how you're paying the loans. So why the human is not going to select see all those data, because that's a huge data even for a one user. What it will do is it will send off all this data to a machine, and it will ask the machine, okay, whether can I give this loan to this person or not. Okay, that is coming from this rule engine. Okay, so okay, so that being said, that is the overview of expert system. Now, can anyone tell me, based on this simplistic way, what will be the limitation of this expert system? Because I might be creating good rules and all that, but still, what will be the limitation of the system? Can anyone unmute, or can anyone type in the chat box? Perfect, perfect. Accuracy, no. Right now we are not looking from the aspect. Input, let's assume the input is correct. The whole data is correct, your input is also correct, but still this as a whole system, this whole thing that you're showing showing in the image, it's an expert system basically. Biased, okay, okay, but you are having a knowledge expert who is defining the rules. So let's assume it is also not biased. What else you can do with that? Rules initiative, that's a very good way to look at it. Even Gauri has said in a similar way. Yeah, I might have a lot of data as well. Anything else? Okay, so the rule initiation is actually the perfect answer with respect to this. Why? To do that, we should understand that we have lots of data. Okay, in current scenario, maybe let's say from 90s, we have bombarded of data because of internet, right? Now data will be in millions, billions. A human cannot do that, right? It is like saying that why calculators exist. Calculator existed to ease our calculation, but what is the problem with that? Like a human can do calculation for 10 numbers or 100 numbers, or maybe let's say 500, 10,000 numbers, but more than that it will take a lot of time for a human to do the calculation, but calculator can do very instantly in just a click, right? Similarly, human can't read all the data, so that is the problem, that lots of data doesn't make sense to a human. Okay, Doesn't make sense. So that's the first limitation with it. So because of that, see, again in this picture you will see the main person who's making expert system is basically a knowledge from an expert. Okay, uh, okay, is my screen is okay? Yeah, now it's coming proper. Now they should be a domain expert with respect to that. Okay, the domain expert should have lot of knowledge, and based on that it will define rules. Okay, but how often they can define rules? Let's suppose I have only, in earlier case of dengue, I have only four symptoms, right? What say I have 100 symptoms? Then how a knowledge worker or domain expert, like let's say doctor, can form a relationship between those 100 setup? It's quite impossible to do that, right? It's like, it's kind of genius maybe can do it, or most people cannot do it. So rules become complex, very complex, if you have more input, or if your data is more. Okay, first data is more, that is one thing, or also if their features or the inputs which define a input data is more, that becomes rules very complex. That's why machine learning come into picture, where human doesn't need to define the complex. So he, in the above image, this rule engines that we are saying in an expert system, that will be taken care by not the domain expert, but by a machine. Machine will make the rules. Our part will be mostly into the giving the knowledge base to that, like maybe the data. The rules will be defined by the machines, and there were certain steps to define the rules also. Okay, so we will talk about that as well. Okay, so this leads to ML. Like you can't have too much rules. You can't make too many rules. How often you can make rules? So that's why machine will form its own rules and try to give us the best possible answer with respect to that. Okay, so that being said, uh, we should also ask that, okay, that might be one reason that ML might form rules better than humans in certain cases if the data is huge, right? But still, the question you should ask again is, why ML becomes so successful? Why everyone is using it right now? Why become ML successful? Okay, it can find rules. Any other reason that you can think of? Why, like you have to think from multiple places. Why common people also can use a machine learning algorithm right nowadays? Extract features. Okay, it can extract, ML can extract feature that as the data increase accuracy rises. Okay, but more in terms of like in a more generalized setting, you're still talking in terms of the specification of a machine learning model. I'm talking as an area itself, why machine, like most of the people of different departments of mechanical, civil, architecture, everyone is using machine learning. Reduces human effort, okay, but that's what a typical computer also does, right? Easy coding process, okay. Anything else? So it is more like, if I give you, your answer is correct, but your answer still lies in the terms of data. You should have to go in more higher level. What I am trying to say is, expert is not needed. That's one of the good answer. Get fit in most of the domains. To do that, you have data, right? So the you can define all this in a three reasons, and in more technical, more higher level. So you can say first is data, which everyone you answer perfectly right with respect to that. Second thing will be democratization, which we'll talk about what is democratization word. Okay, and third part is something, is the devices. They're like 3Ds kind of thing. So what do you mean by that? Data means now you have internet, okay? You have lots of data. You have social media, you have Wikipedia, okay? You have text data, you have audio data, you have video data from YouTube. So data abundance is lot of them. Obviously, so the more the data, as someone said, more the data, the better the model will be, the better the accuracy. That's perfectly fine, okay? But still at the data level, right? Now, second, to assess that data, you how a machine will learn that data, right? For that, it comes down to democratization. That is, we have lots of open source model or the algorithms, right? It's not like, so if you're making a neural network or a deep neural network or a convolution neural network is not something hidden within that Google hides it, that okay, he's not telling that how CNN works or how convolutional network or how LSTM works. It is, everything is open. Anyone can understand this algorithm and build their own model on top of that. Okay, that's a democratization. Everyone knows it's publicly out there that what algorithm I can use, what is the pros and cons of the algorithms. So everything is out there. Okay, now third most important thing, where it is separating the huge companies from a researcher, academic research or general public, is the devices. Even a simple person right now, a normal person right now, can use something like Google Colab or cloud services, okay, services to access the machines, which is like a more like cheap devices, you can say, like in a very free, in a free of cost, or in a very minimal amount of cost, you can access the devices and you can train your data or model on top of that. So these three make availability of the machine learning model or training or understanding machine learning model more successful in as a whole domain. Yeah, I think Subbu Lakshmi has raised the hand. Can you please unmute and you can tell what is your query? Okay, so again, this is more like a higher abstract level, but you should know where these things are coming from. Why you're even attracted to deep learning is because you will get, you will get data from somewhere. You may get data from uh, Kaggle or Google AI there, or uh, machine learning repository, multiple places. You know that democratization. Okay, you asked me to do. Okay, democratization means even to machine to learn a model, uh, or basically computer, machine is basically computer, right? It needs certain steps, it needs certain algorithm, right? How you search within a computer, if you're given a data, a set of 1,000 uh, uh, data points or the 1,000 rows, columns and all that, if a machine needs to learn to search, how to search from that, you make certain algorithms, right? Even for machine learning model also, you have some learning algorithms are available, which that is what you're going to learn. You will learn the mathematics behind how the learning is, how the classification will have, and different type of algorithms. Like you might have heard of random forest, you might have heard of decision tree, you might have neural network, you might have heard of RN and CNN. They have different kind of learning algorithms, which is used by machine learning, used by machine to learn the data. Okay, I think Gauri has raised the hand. Can you please unmute yourself and ask what is the question is?
Actually, what is the percentage of? I understand that you are saying ML has become successful, but still I doubt that how much success we have received here. Like accuracy, can you tell in terms of accuracy?
Okay. So my way interpretation of successful here is, it's more like a why ML as a practice has been become successful, not as a product. So like it's like programming language, like coding, right? In 2000 or late 90s, people started coding in India, and now by this 2023, most of the people should know coding by that. This is a kind of default. People think that if you're coming to engineering, you should know a certain kind of coding with respect to computer, how you code to a computer, right? Similarly, ML is also like a tool. See, consider ML totally as a tool. It is nothing specified that it is something separate subject. It is considered as a typical tool that you're going to use for your own purpose, like how you write a code to make a website or Android app or any other thing. Similarly, ML is also just like that, to help you to make certain decisions, right? So that's what I'm telling in terms of success. Why more and more people are adopting ML as a thing. And coming back to your question, yes, accuracy, yep, in very specific domains, it has been very successful. For example, if you use Instagram, you use filters on that. So just try to think that how machine, or just your camera, front camera, detecting your face, and on top of that it is attaching certain facial features, a kind of as a filter, right? That's a machine learning. It's not happening by default. It's not a static algorithm that is uh, which has been created by someone. It is a machine, your processor in the phone try to extract the where my face is in the screen right now. You can see that my face is little bit, maybe the left side, maybe the right side, or maybe in the middle, right? As a eyes you can understand, but how a machine can understand? That's what the challenge actually comes upon, and we will see that how this whole thing that you're seeing on your screen, how machine is able to understand it whole this thing. So whatever you're seeing on your screen has to be understood by machine also, right? That's why it can show up to us. So that's what I'm telling as a successful thing. Okay, so again, the coming back to topic with respect is why ML has become successful in terms of adaptability, as an adoption of the practice, is because of this thing: data democratization. That means you have tools and techniques to make the system learn about something. The algorithm, everything is open source. Most of the things are open source. Now devices, you have some devices like we will show you if you have used Google Colab. If not, I will show you Google Colab in this maybe next part, where you can develop your own code for machine learning. You will use the data and you train the machine to do that, and it is all is free. You don't have to pay anything for that. You can practice all your codes in that Google Collaboratory or Google Colab notebooks, right? So this is there. Now for example, ChatGPT, where the everything, where the people are like big companies like Apple or machine OpenAI or Twitter, these people are ahead of us, is mostly because of this data and devices. They have the amount of data we might have, we might be 1x 1% 2% of data that they might have, right? So the more the data, better the thing. So that's why data, in the data, that's why company is ahead of us. Second thing is devices. The computation that they have doing in devices will be so big. Like you consider there's a 7-story building in your nearby places, they will have all the computer sources only for that, and from that they will try to do all the computational tasks. So they have that much resources for that. That's where the typical people companies are ahead of us. But where they are not ahead of us is the models. Even you can learn whatever they are doing, even you can understand with respect to that. You don't need separate aspects of that. Okay. Now, maybe this another point might be interest of you, that let's say there's a ML world. Okay, there's a ML world. We can divide this ML world into three aspects. Okay, now we will try to understand where you exactly lie in this three pyramid. It's a kind of pyramid that you are having. Okay, so the lowest level is the data, where you collect, you will curate the data. Okay, so in this ML, this is a pyramid. The lowest level is the you can collect the data, you can curate the data, and you can define some tasks like what to do with that data. Okay, that's the first thing you can do. Okay, now second thing is, it's more like, okay, now define the data. Now I have maybe hundreds of machine learning algorithm right now. Which one to choose? Which one is better for me? That is something defined by which machine learning model. ML model I'm saying, okay, which machine learning model is suitable for the task that I defined for the respective data that is there. Now the top of the pyramid are the one where you're talking about the fast, efficient, and maybe better way of solving, better way of finding techniques to learn, to train a machine. Okay, these are three pyramids. Now let's see how you can define. These are the basic tasks or basic ways of defining pyramid. Now most of the people who will be lying here in the defining task or collecting, curating data. Okay, here can be general users. Okay, now here can be ML engineers, and last top of the pyramid will be ML researchers. Okay, so what do we mean by that? So let's take car as an example. Okay, let's take car as an example. So you can say that this, uh, this the top pyramid will be suppose is a car company. Okay, which want to create a car of car for general public of a specific specific kind of thing. Uh, just a minute. Sorry. So car company will say that, okay, I will try to, is it visible? No. Okay. Just a minute. Screen, share the screen again. Yeah, the car company, what it will do is that it will for, like, suppose you are a traveler, so you will try to make a car which can run in a heavy terrain or rough terrains, kind of like. For a general public, it might be doing in a way that I just need a fuel efficient car, something like that, right? So top of the pyramid will be the car companies or the researchers who try to make car more efficient or specific to the purpose that they want coming. Can anyone can see my screen? I don't think so. You can see my screen. Let me reshare again. Sorry for the interruption. Um okay. Yeah. Now I think I can also see the screen. Um, Okay, I think I have a little bit net issues from my side, I guess. Okay, so that is the top param. Second will be the people who will be maybe like a salesman, or the people who are selling the cars are kind of like that. So I will, as a user, I will be the user. Obviously, the bottom pyramid will be the user. I will go to salesman, tell, okay, this is my requirement. Suggest me a proper car. So they will suggest me proper car, and salesman will also tell that, okay, this is the kind of requirement a general user have. So build a kind of uh, cars for that kind of requirement, right? So the car companies will take the suggestion of ML engineers and try to refine the techniques and how they build the cars and all those stuff. So that's the ML world will combine to. As a general user, you will collect, curate what you are trying to learn right now to become a ML engineers. Okay, so for example, just to give an example, CNN is called convolutional neural network. It is good for images, but it is not good for text, but people still use it. Okay, it is pretty good, pretty powerful for understanding the images or videos and all those stuff. Okay, RNN in reverse is very good for text handling, understanding the text, the meaning, what is happening in the text, but it's not good for videos. It might be shown for few works, but not for majority of the work. So these are things which ML engineer decide. Once you have a data, once you have a task, now which model I should use in Justified. ML researchers, if you want to do master's PhD or something with respect to that, ML researchers say that, okay, we have existing algorithms. ML researchers know that, okay, this algorithm has certain problems. Now let me try to define it, make it more faster, more efficient, more better. Okay, because computational requirement for a machine learning is still very high. It's very high. So give you an example perspective how very high it is. So there's something called as transformers. You might you might be introduced by transformers in deep learning. If not, I will introduce to you. Now transformer is something is okay. CNN is convolutional neural network. This is a type of neural network. We will talk about this in future sessions for sure. We will build it from scratch also. Okay, RNN is something called as recurrent. Yeah, I will share all these things. So if by the after this session is over, upload this video, as well as this folder will be shared with you, where you can go and check that date wise. I will put it there. Okay, so RNN is recurrent neural network. Okay, so these are pretty old, like these has been proposed in 1980s 19s, but since the machine capability has improved, people are using it right now. So again, coming back to topic, that the ML constitute lot of computation power. What it means is transformers is something which has been proposed in 2019. People started using a lot. Okay, it has something called as 113 million parameters when it started actually. Okay, when it has been proposed by Google. Okay, or some not 130, maybe 10 million parameters. You know how much energy it has consumed to train the model of this transformer? It consumes at least carbon. There's something as carbon footprint, right? It has taken the lifetime of 5 cars. So let's say you have a good car which is running for, let's say, 20 years. Whatever the carbon dioxide has been emitted or energy consumed by the car, by 5 cars, it's equivalent to the for training one machine learning model of transformer of certain 10 million parameters. We will talk about all the jargons that we are talking about. I'm just trying to get you some intuition about that the field that you're coming in this right now. is something, it's becoming very, very huge. ChatGPT made it so huge right now that the data you're talking about right now is not in hundred thousands or millions. It's right now in billions, billions of data, billions of parameters, making it and machines trying to learn that, and it takes machine learning model takes months and months time to learn certain things, right? So the scale is very, very huge, and I want you to appreciate with respect to that. And within this pyramid, we are lying in the bottom two. The top one is something people, if you want to go and explore more like that, you can do. But right now, try to appreciate which ML model and what data you want to work upon. Okay. Now that being said, uh, we will talk about 6 elements of ML right now. Okay, this is like a consider that as like intuition for the whole course that we are going to have. Okay, 6 elements or 6 jars you can say for this whole course. Okay, if my voice is breaking, please give me a time. Maybe the internet issue is there from my side. Today the net is little fluctuating in my institute, so if that is happening, please bear with me. Otherwise, in this recording, mostly the voice will be perfect because I'm directly using the microphone attached to the system. So hopefully it will be better there. Okay. We will start with this. Maybe we can take 5 minutes break, something like that, and we will go to this. It's more like a defining. It's like more like a defining framework for machine learning. And just to before leaving, just to give you a simple thing, understanding that where you stand lies and all, this is whole circle is AI. In that small part is machine learning. Okay. In that small part is deep learning. Okay. So we are going to focus on that. But to understand this, you should know some basic framework of machine learning, which is applied in this deep learning as well. So that is what we are going to talk about in the after maybe at 7 o'clock we will start, and we will define what are the 6 jars are or uh, six elements of machine learning that everyone should know in mind, keeping in mind when they started learning any deep learning or any machine learning thing. Okay, so that being said, we will take a break till 7. After that, we will come back and we'll talk about 6 elements of machine. Okay, and if you have any question, please type down in chat. Give me 2 minutes. I will come back and I will try to query. I will answer your things by that meantime, and we will start us again this session by 7 o'clock.
Hey, one small clarification from my end.
Yes.
So I think so I got email for 3 sessions, right?
Yes.
So it's for upcoming week also, right?
Yes, yes. So the same link that you're using right now, I have a specific link, Google Meet link. So these other students might also have specific Google Meet or some other system, other software they might be using Zoom or any other thing. So they have every Friday or every Saturday, that same time they will come and they will have session. For me, every Tuesday from 6 to 8, I will be here taking sessions.
So we need to attend all the sessions.
No, 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 no. It's based on yours thing. So maybe what you can do is, for first few sessions, you might attend every single thing, and you decide which session you might liking the most, which kind of approach. For example, my approach will be more basic. I'm assuming that you don't know anything. I will take mostly a very high level, not going to mathematical level. So that is way of my approach. I might not solve most of many assignment problems right now, at least in the starting phase of this. Right now I may do maybe after 3-4 weeks, but other might have a approach that they will start solving assignment problem for the first go. So the approach of all the TAs will be different, so you can decide among that which one suits you according to your needs.
So I think it's good if we attend at least one session, right?
Sh-
Weekly one session.
Yeah, I think that will be a good way of looking, considering if you have time and you can because they might discuss some other important aspect, because it's only mostly a one-way communication is happening. So that's why it's good to attend at least one session if you're finding it useful, obviously.
Even right, see, I'm also looking for from basic level only. I'm also from mathematics level, right? So I think it's out of that.
Exactly. I totally agree with you this. So that's why I'm what approach I am taking here is that you might have to look multiple times the same video to understand the mathematical intuition, or you might to know some basic other touch up that vector matrices, which I will try to cover within this session or maybe next session, uh, about vectors and all, which you should know some basic things which help you to understand the algorithm that they are having. But mostly I will focusing on that. Okay, if I'm saying let's build a convolution neural network, how to build that using Python code or some other code. So I will be focusing on that aspect.
Oh, great, great.
Okay. Uh,
Thank you.
Sure. So yeah, I will try to discuss assignment questions also, but I will start since I'm assuming that to get to a assignment question, you might also know certain before basics. I'm touching that. I will try for that mostly after, but I can say that after 3-4 sessions when it will be uh, become little bit more complex right now. But I will tell you sources and all what you can touch. Obviously, we can discuss. It's not like only 2 hours. After 2 hours, also we can extend. We can discuss all with respect to that, and I'll try to help you. And this another question: how many session per week? For me, this every Tuesday from 6 to 8, I will be having only once hour. I'm having, but there are other two TAs are as well, which is having live sessions, and you will get notified by NPTEL. So it is, I think one is happening on Friday and one is happening on Saturday.
And then one more thing. So these recordings, right? So where can we find?
Okay, so in the Swayam in yeah. So in Swayam portal, where you are getting the week 1, week 2, and assignments and all. If you check at the left hand side below, you will have something called as live session, and if you click on that, it will redirect you a Google Sheet where you will get this recording of YouTube link. I will once it's done, I will upload it to you Google, and whatever I'm writing in the doc right now, I will upload it to a one Google Drive, so that link will also be available. So there you can access all this stuff, not only for me but for others as well.
Yeah. Because while we are checking, right, we saw only last year's live session.
Yeah, it will, because it just started, like live interaction just started right now, maybe last week Friday. So that's why you might not see all this thing. But we will really, as this is the first week of mine as well for this course, first interaction session. So over the period of time, we will have 12 interaction session for each student right now. So you will get all the links for sure.
Thank you.
Yeah, sure. Okay, I will show the access of recording as well. Maybe at the end of the session, I will open and I will show you how to see the access of recording. Okay. Yeah.
Sure.
Hello, sir.
Yes.
Sir, good evening. This is Shanmugam. So, actually, I enrolled my PhD. Yesterday only I registered for this link. I
Okay.
think from my supervisor.
Okay.
Okay. So, I got to the website. I mean, I got to your portion already. The 1 week portion has been completed, right?
Yeah, like so it's more like this, like the session when we are having, by that time at least 1 or 2 week of portion have already has been published by the NPTEL from their side.
Sorry, I can't hear your voice properly.
Okay.
Just a minute.
Okay, just a minute. Let me turn off my camera so that the network will be less. Now, can you hear me?
Yes, yeah.
Okay, so NPTEL uh, publish week by week material based on every week. So right now it started from 24th or 25th July, if I am correct. So it has published today, I think published 2 weeks. So maybe by next Monday it will publish the third, like that. So there's a buffer of at least for us who is taking live interaction for at least 2 weeks of data, 2 weeks of course material that has been shared.
Okay. So we have, I mean, we don't want to avoid for the first week of session. So is it possible to get it to this week for the whole, I mean, the last week session over here, right?
Yes. See again, the content which has been shared in the by NPTEL or the faculties who have uploaded their videos, the content they are having and the content we are going to have slide. The concept will be same, but the approach of telling, like right now, the first hour I'm only discussing about the expert system like that. This has not been discussed in the course as of now, if I remember correctly, right? So little different approach might be there, but that is but you have to see the other sessions also how they are dealing with.
Okay.
Yeah,
Anyway, thank you so much for
yeah,
that.
yeah. Thanks.
Yeah, please go ahead. Sorry to interrupt.
No, that's fine. So give me 2 minutes of time. I will come back and then again we will start because already 7. We will start again from the 6 elements of ML from that. Okay, so welcome back. We will start with the session again. Yeah, I will share the notes. Like everything will be shared by you with NPTEL, and at the end, I will show you that from where you can access from the SWAYAM portal. Okay, so let's start with the 6 elements of ML. So what I'm saying in this is nothing new or something like it has been pretty much established, and what you're going to learn from this 6 elements of machine learning will be applicable to deep learning as well, because deep learning is a subset of machine learning, right? So that being said, we will start with that. So the first jar is basically is mainly is data. Pretty obvious, right? Which is you can say as a fuel for ML or any deep learning models with respect to that, right? So why data? So we need data, and data will coming from the format of text, audio, video, images, whatnot, right? Tables, right? So data is humongous. Like we have all this type of data is there, right? But only having data is not sufficient, right? Now, data can be classified for a machine learning as two things. The data should have certain inputs, it should have certain outputs, right? I just can't just give tests and ask the machine to tell me that, okay, don't make some sense out of it and just tell me what is in present the data. I should have certain inputs from the data, I should have certain outputs of the data, right? Why do you need an output? That's a one of the question. Okay, input is okay, that's fine, but why do I need an output? The reason you need an output is to such that it can understand some example. Like for example, if you are to know that you should know that 2 plus 2 is equal to 4, you should, if a teacher says like that, it will also give certain example that 1 plus 3 is also is equal to 4, right? or maybe 2 plus 1 is equal to 3. Like teacher gave example with respect to that. So that's how human also learn. Right? Similarly, for given input, we should know that what kind of output I am expecting. Right now, once I have this component which is already present in data, I will call it as something called as supervised learning. That means I have a data set. In that data set, I have certain input, maybe any, let's suppose this itself as a jar. Now you can see that these jars are there. If I give one jar to that, the machine should know that it's a jar, right? It should caption it as a jar. But to caption it as jar, it should get multiple different type of images of jar as a data set to train among themselves. And when I give this jar as an input, it should automatically autify as a jar. So machine should know that okay, what the machine wants to do, what the output he wants to give, right? The machine wants to give. So that is something. That's why output is needed along with the input, and that is one major thing with respect to the uh, data. Another point that we need is another point which we need is data should be available in machine format, machine readable format. So machine I'm going to write as MC m/c, okay, machine readable format. So right now you can see that data should be available machine readable as a human, right? You can read this thing, but do you think that machine will read the same thing what I've written on this doc? No, right? It will take it either as a pixel or either as some other values, either as one and zeros, some value, numerical value associated with that. So when we are seeing machine readable format, it is basically numbers. Your task is, if you get a data, how to convert that to a machine readable format, that is basically into numbers. So in what format that this number should be, that is something we will discuss after few minutes. Okay, that's the first condition, that if you have a data, what to do with that. Second thing is it should be numbers. Third thing is there's something called as dimensionality. So data should be of high dimension. So what do we mean by that? Data should be high dimension in a very literal simple sense is that a text, let's say I've written some text, I should have multiple example. It's not like if I give just as a as an input and I ask the machine to interpret it as a, it might assign one number to that. Okay, let's say I give them machine as another input, it may assign maybe some number to that, maybe let's say 28, 29. Let's assume like that machine, they say whenever the word machine will be there, it assigning 28 word to that. But if I'm giving a page of the book, it can't assign because the words are very high. Okay, and we are not even talking about, we are trying to make sense of that page, right? So a page will typically will have 500, 400, 500 words. So how to make sense of that? So it has to plot the data into certain space. So we will talk about high dimension space or Euclidean space, something called as Euclidean space. Okay, so what I am trying to tell here is that the more the data we are going to have, since we are going to deal with high number of data in terms of quantity as well, also in terms of representation. When we're going to represent the data, it will not going to represent in 2D plane. Okay, I can't represent text in a 2D plane of x and y coordinate. I can't do that. I need some better representation, and for that representation, it will be more like a kind of space will be there. Like you might know 3D space in the world we are living. It's called a 3D. It has height, width, and length, right? But this is for our interpretation. But for machine, it may go beyond that. It may go for 4 dimension, 5th dimension, 100 dimension, something like that. We will discuss all this as a jargon, but just to try to understand that if you have a lots of data, to present that data and put it somewhere, it's more like you have lot of furniture and you want to arrange in that room. You need that kind of space where you can arrange 10 different furnitures, right? Similarly, if you have the data, machine should need to put it somewhere to make sense out of it. to make it more understandable. That's what we call as high dimension space with respect to that. So it should be of high dimension. Okay, if you're not able to understand, still fine. Once we go more deep into that, you'll get to know what is dimension we are talking about. Okay, we'll get to know that. Now the next question that you can typically ask, where I can get the data from. Okay, so let's divide this into three aspects maybe. Okay, where can I get data from? First is, I am lucky that people have already done their job, they have given me data, I can use the data to train or something like that. That means you can search something called as Google AI. It has large set of data sets. You might have Kaggle. Kaggle is another website for where you can practice your deep learning, machine learning problems. Okay, from government there is something like data.gov.in, which where you will get lots of agriculture data, climate data, other statistic data with respect to our country. There's something called as UCI, machine learning repository. Okay, so people have already curated data for you. You don't have to restart the process unless you're doing very specific, very narrow domain where you're not, people are not focusing. Okay, this is one kind of data. Second kind of data used by corporates. Okay, now corporate is more like, you can say I am rich kind of statement with it. So what they're doing, they're building a kind of crowdsourcing platform. Okay, to give an example, obviously you might have looked at that you are going to a website and they're asking that verify as a human, and they will ask you that among all the 5-6 images that they are showing, which has bike, which has truck, or which has traffic signals, like that, right? And you're clicking on correct images which are there. If you select the correct, they will say like that, then it will be then if it is correct, they will not actually have as a correct, but they will take it as your input and will train the model behind that. So crowdsourcing platform is, they will ask people around the world through some games or something, where they will say that okay, this is the image, now tell me which image it will be like. Okay, so that is what people do. So there are multiple things are there, like some data called data turks, which do this all of stuff, or something else, Amazon Mechanical Truck, something. These are companies which, what they do is, if you have millions of data and you want to annotate the data, that tells that what data is actually is, you may just give the normal user as a game, and the user will take it as a challenge and try to say that okay, this data is this data is this. So based on that, it will try to annotate accordingly. Okay, my voice is not clear. Okay, thank you. I will turn off my video. Okay, that will be better. Okay, it's difficult to understand. Okay, please please also tell me that where you're not getting. I will try to explain it much better. So I'm still in the terms of data right now, right, where we can get data from. So how corporates get the data from us, like that. And if we are lucky, we have lots of existing data sets. Okay, or you can create, third type will be, you can create your own data, right? So the first jar of the machine learning is basically is data. That is something pretty obvious for every single thing, right? Now second thing, we'll just talk about second thing in this case. What is the second jar of, second important component of this? So let's try to take an example. The second jar is basically, which will tell us task. Okay, now what is task we are saying? So let's assume we have a Amazon product page. So we have this Amazon product page. Okay, here there will be the image of the product. Here some they will tell about what the product is. Okay, here a table will be given which tells about the specification of the product. Let's say mobile, there's a mobile is there, that's the most. Here in this part of the page, they will have reviews, like that. Okay, now I have this data with me right now. I have certain images, I have some text which tells about what the product is. Now to get to know more technically, I will have some specification table about that mobile phone, and I will have reviews made by customer that how that mobile is going to be like. Okay, so this thing is there with me. Now if I give it to the machine, will it be able to understand? Most probably not. So what we can do? We have to tell the machine what I gave this data, what you have to do with that data, right? So let's take multiple examples with respect to that. So one thing you can say that, okay, this highlighted green part is the normal description of the product, right? So from that I can ask right now that from this unstructured information, we will call this unstructured because it's just like a text, normal text, no tables, nothing. From now information, create a table for me. Okay, so this will be the input for me and create the table will be the output for me. Okay, this can be act as a one task. Another task that you can take is, okay, I have table info from the specification and I have reviews. I have these two datas with me. Now as an input, create a FAQ for me. So for example, some people might uh, start saying that, okay, what is the uh, uh, how much battery our phone has, for how long it will do. So in the reviews you might get it, but it not you might not get in the specification. So if someone asks in Amazon, you might have seen some question that how long the battery will work or how good is the camera and all. So you get that information automatically. The machine will try to understand from that and try to give automatic create a FAQs for that. Okay, frequently answered questions, right? So these are the tasks that you have to define. Now once the reason you have to define here is, once you define the job, the machine will start understanding that, okay, I need to do certain tasks. Okay, so this is still a very abstract example. Okay, now yes.
Hello, sir. When you start solving assignment problematic types?
As of now, I'm not going to do that for at least 2 or 3 weeks because I will be covering the basic aspects of that. Mostly, I will covering Python, the the libraries that you have to use to build Pythons, and also it will take some time for me to go to
They are
assignments.
saying that the link to solve assignment, it's nowhere it's connected. All you are teaching only basics. It's available in online most of the
Yes, ma'am, that is true. That is the other two sessions also which might be doing the solving problems. My way of approaching is that most of the people might not even know this stuff, so I'm taking everything from scratch.
But they have given that it helps you to solve the assignment question.
That is true, ma'am. But NPTEL also gave us the liberty that how to we can solve the problems. So I'm taking this approach right now.
No, it's nowhere connected, sir. Thank you.
It's okay, ma'am. That's totally fine. Uh, yeah, sorry. So now once you get this, there are certain predefined tasks for machine learning that people will uh, uh, try to get it off from the system, right? So when I said this, so these are something called as, if you want to know, I'm telling you beforehand, this is something called as image captioning. It's a kind of problem already available in machine learning, deep learning domain, where you get a image or some text in form of image, and machine has to understand and give me a caption that what that image looks like or what is there into that. Or you might have seen in Facebook that that if you send a photo, upload a photo, it automatically tags different your friends automatically. So that is a kind of machine learning problem that people are trying to do. But in this course that we are going to do, their task can be divided only into two types. Okay, so it can be divided only into two types, which is called as supervised. Another is unsupervised. Okay, so these are the tasks that we are going to mostly deal with. In that also we will mostly focus on supervised learning. For that reason I will tell you, in that there are two type of tasks people mostly deal with, that is classification and regression. All these things you will see from the perspective of deep neural network if you don't have any background of machine learning algorithms, but still it will be deals with the from the perspective of classification and regression. Okay, so classification is basically tells about whether I have a dengue or not from the starting example, or whether I want to, whether given a if I want to watch a movie and I have this like, okay, it should be a need to a specific music director, specific actor. So whether I will watch the movie or not, that's a kind of classification problem. It's a like a yes or no problem. Okay, regression problem is more like a continuous variable problem. That means uh, so like a housing problem. Okay, so housing problem will be like, if you given me the size of the house, okay, the amenities available in that house, okay, the locality and all those stuff, I have to predict what will be the price of that house. Now price of the house will be a real number. Okay, the real number is like, if you have in terms of jargon, like I have 1 to infinity number, so I have real number 1 2 3 4 5. This is real number. -1 is a real number. The distance between 1 and 2 also, in that also they will be more infinity number, that you can say it's 1.1, 1.5. These are all real numbers kind of thing. So that's what we are talking with this regression model. Okay, so that is these are kind of supervised tasks. Supervised tasks means, for a given input in the training, while I'm training the machine learning model, I will give the input also as I will give the output as well. Okay, so without, and the task of the machine will be to map input and output. Okay, that is in general what is supervised learning. Unsupervised learning is basically unsupervised learning will have only one aspect, that I will just give the input and I want to make some sense of the data. So for this there are two tasks which has been defined. One is called clustering. That means let's suppose there's a 2D space and I have certain points. Okay, now machine need to decide that has to group certain points to in a one set, and select red into one set and the blue into one set. To learn that automatically without having any output label, what it will do is try to form a line and try to see that uh, whether it is able to fit cluster all the similar type of points into one circle or not. Let's assume a circle, right? Kind of like that. So it will do multiple iteration for that. So I'm just giving an overview with respect to it, but clustering is what do it. It try to club similar data together, and you don't know what the output will. This person will not know. The machine will not know whether the red point or red point that we are seeing as red point is actually a red point or it's a blue point. They doesn't know. It just know a point in the space, and its task is to divide this as a one plane or by a line. Say that okay, red points are above and blue points are the below, like that. Okay, this is one. And another type of unsupervised learning that you might be talking about right now, many people, is generating. You might heard of generating AI, like you give set of images automatically and it tried, or you just give a certain input and the machine learning model generate a image out of that, or like a chat GPT, it will generate text out of that. So this is something unsupervised. You're not telling that what the output would be like, you're generating output based on the query automatically. Okay, so this is a more higher level form of AI that we is not going to touch upon. Mostly we are going to touch upon supervised learning. Why? Because in this current today world, 90%, 99% of economic value you are getting, any company is getting some economic value from machine learning is coming from supervised learning. Okay, so whatever task they are having, it is a basic supervised learning model. So that's why we should know that once we have a data, what kind of task we should have. So that is the second jar in our case. I think Shubham has raised the hand. Please uh, unmute yourself. You can ask the question. Okay, now you have the data, you assigned a task. Now the third part will come. The third part is you can ask starting by asking a question is, how can you mathematically, or like what is the mathematical uh, formulation of a task. Okay, now when you're saying that, okay, I'm going to use classification problem or as a supervised problem, or the one we said in the Amazon product page, right, that how to create FAQs and all. So how you can define it the mathematical problem. Why you need mathematical problem? Because anything you're going to give it to computer, it's basically numbers. So obviously you have to deal with numbers. To deal with numbers, you have to form mathematical models, right? So third jar talks about the models in terms of like that. So how you can define the model as a mathematical problem, right? To give an example for that, uh, let's say a 2D space is there, okay, and has certain points of like that. Okay, now I want to know that I want to make a model which can fit this, which can go through all these points that I'm just have posted like that, right? So what are the ways I can do this? I can start with that. So what machine learning models start with is basically is approximation. It will start with certain random point and it try to approximate that, okay, whether I can cover all the points or not. So that's what it tried to do. So for example, there's something called as y equal to mx plus c. Okay, what is y equal to mx plus c? It's basically a line equation. It's basically a simple line equation. Okay, what does it means is in this 2D space of x and y, okay, I will try to fit a line like this. Okay, but you can see that when I'm putting a line here, I can see that many of the points are not being uh, going through this line. That means this equation what the model has proposed is wrong. It is giving a lot of errors with respect to that. So what I will do, I will try to form more complex equation. So let's say uh, ax square plus bx plus c. So it is a polynomial equation. Okay, now it is a polynomial equation. Now polynomial equation, what it will do, it will try to fit the line here. We can see that it is better than line equation, but still not better. It's not still not covering the whole lines of kind like that. So still this might not be a better solution for me, right? So what it will do, try to go more complex with respect to this. So what it might propose that let's have a 3-degree polynomial equation that like ax b square uh, ax cube plus bx square plus cx plus d. See all these right now I'm talking with respect to line equation. All these are line equation only. You're trying to make a line in this 2D space, try to cover all these blue points, right? Now I will try with this. Now this equation will maybe it will try to make certain kind of equation, the yellow line if you can see, or let me make it as a green line. Okay, now we can see that a 3rd-degree polynomial equation might able to cover the most of the lines, right? That's our assumption will be. Now the question will be, okay, let's assume that model identified this thing, that okay, this equation might be good for me this task to cover all this line. Now my next question would be that what are the certain called parameters are there, that is a b c d. Okay, so a b c d, there's certain parameters are there. Okay, so what values of this equation will make me fit this line. Okay, so for example, how can I say abcd is, to give another example, if I'm making this line, it has 0, let's say it is 1, this is also 1, this coordinate is 1 1, kind of like that. Okay, so if I'm representing as like y equal to mx plus c, okay, here my c value, it is basically 0 and m value is 1. So it will make as like y equal to x. That's why I have 1 1 as a coordinate. Okay, uh, if you're still not able to understand, I will ask you to go and read more about the line equations per se. Okay, that is one thing. So again, coming back to the topic, this is like what we are finding for the value of m and c, and to make point of 1 and 1, I found that y and x should be equal. To do that, I impose m, I gave 1 value to m and 0 value to c. Because of that, I get the equation y equal to x. Similarly, to fit this line, the maybe a kind of wave line that you can see. For that, I need to find proper A, B, and C, D values, which we call as parameters. Okay, so this is something we need to decide. But we will stop till this point for this model, till the point that it identifies that okay, this might be a correct formulation of this. Okay, now once we get this, now natural question that you might ask me, that or you should ask yourself, that why I started with the simple equation of 1D line, why why can't I directly go and start with the more higher level, that let's say I will start with ax raised to 25 plus bx raised to 24, that is in the order of raised to 25 thing, right? It's a more complex equation like that. Why I can't work with that? So the problem is, the more complex you will go, if the data is not complex, there's no need to go to the complexity. For example, if I am having again a data point, instead of like how the data we are arranging like this, right? It's a kind of wave equation is there, but instead of that, my data is actually like this, simple like this, and I can fit that line, I can cover all this point by stating a line. Yeah, now it's it. Now I just by stating a line, and I can cover most of the points. So it comes with the basic of mx plus c equation. I don't need to go to higher order of polynomial equations, right? So what I'm trying to say in gist of this, that model always, a machine learning model always try with simple equations, simple mathematical formation, and it's our job as a humans to tell that okay, you should look at this family of functions. So for example, since it's a 2D space, I'm taking line equation as the family of function I'm taking, right? So similarly, we should tell the machine that okay, you look at the if you want to define the machine learning model, look at this type of functions. You can give all type of function and it will take a lot of computation time, but to get more simplified, you give some family of functions with respect to with respect to mathematics, right? And when we're talking about neural networks or deep learning networks and all those stuff, they have their own set of mathematical equations. So what I am telling is not something, it's very basic, very in a very high level way. But the neural network, NN is neural network and DL is deep learning with respect to that, deep neural network you can say. It has its own mathematical equation which you're going to study in the course over the period of time, right? And that family functions, this model take and try to converge means try to arrive a point where they say that okay, this is the max to max I can do, more than I can't find more relationship between a input and output. Okay, so that is one thing. And other thing that you might you will going to read with respect to model is something called as bias, something called as variance, something called as overfitting, something called as regularization. So these are some jargons that you're going to cup up within this course, which talks about the importance of choosing a particular kind of model, right? You can't just tell that okay, for this task I will directly take neural network. You have to justify why you're taking that thing. To do that, you have to define the family of functions. How you'll do that, you will see. You don't have to define per se, it is already existing. You just have to understand that why that family of function is there for the particular problem. Okay, so similarly for this case, even for a 2D space, if I have a certain number of points, I can take different kind of polynomial line equations. Similarly for audio, speech or any kind of different data, specific set of family functions are already defined. You should just need to check that which model I should will be suitable for that particular kind of data. Okay, so this is the, and I will come back to this point of ABCD parameters, because this is another important parameter. Okay, I have defined the equation, that is fine, but how should I find this parameter is something I need to discuss, I need to decide upon, and what machine will do on top of that, right? So again, coming back to topic, we have the data, we have the task, and we have something called as models. Now models are basically functions, mathematical functions, which you're going to use to achieve this task, whatever task that you have defined. Okay, now once you know that, okay, this is the mathematical function of the model I'm going to choose, okay, the next question will be, the next question you should ask is that how do I know which model is better? For instance, let's again go back to the previous example. This one, okay. Now, based on discussion, we found that y equal to ax plus ax cube plus bx square plus cx plus d is my better model or better mathematical equation to fit a line for these points. Now, I might propose another thing. I might say that, okay, no, I don't want cube. I have a raised to 5, bx raised to 4, cx raised to cube, dx plus e, something like that. I have another higher level complex, more complex equation I have. Okay, so I need to understand that which model is better for me, whether this y1 or y2. If I have to understand with respect to that whether y1 is better, y2 is better, we need to understand something about loss function. So, if I am saying that how do I know that which model is better, I should talk about loss function of a particular model. Now, what loss function is? That loss function is, I know the output, like basically, for example, again, let's take another example with respect to this. In this only, I will again try to form this thing. I know the actual values of this point, the actual coordinate of this points. I know this value. Okay, so if I know this value, that means I know the correct output. Okay, and the line which is trying to fit that thing, I know the distance between from that line to that point. Okay, which we can say in this case as an observed value, because trying to predict that point within certain point line of points, right? Because line is also a set of points, so it is considered as an observed output. Now, what I will try to see is what is the difference between these two entities, correct output and observed output. Okay, so if my difference is high, I will say my model is not bad. A model is bad. Okay, that means my prediction or the model prediction is not coming close to the actual data which I am trying to predict, right? But if my difference is low, I will say that model is good. Model is good, which means that model is trying to capture the data in a actual way with certain errors, because obviously you can't have a perfect model with respect to that. You can't have all the models as perfect. So how to get a more mathematical intuition or geometric interpretation of this? Again, let's see like this, that there's this set of lines, these sets of points are there in a specific order. Okay, and my model has say that, okay, this is the line with certain value of y equal to mx plus c. Okay, now what it will do is, from this line it will try to find distance between all the red points which are not present on that line. Okay, so for that it will find some distance. So let's say y is the actual output and f of x cap is the observed output or the predicted output. Okay, so what I will do is I will try to find the difference between them or the distance between them in this case as sigma of I equal to I to n yi, which is the actual output, and fx of I for that point. So for example, if my y is 2 and the fx of I, the function that has been made by my model, is giving me 1.8. So there is a difference of minus 0.2. Okay, so this difference, there is something I want to understand. So I'm raised to square. So why we are taking square and all, we will discuss maybe when we go to the actual loss function. But this is called as squared loss function. Okay, so what I am trying to say tell is, to get to know the model is better or not, what I will try to do is I will see the predicted output and I will find a difference between the predicted and the actual output. Once I get that output, when I get the differences, I will square it and I will try to get the estimation of what exactly my model is behaving like, whether the differences are high or differences are low. This will be tell by my loss function. Okay, so this is the gist of loss function per se. Okay, so or in another way, if I have to tell, loss function will tell that if my equation is equal to fx, if it's like ax cube plus bx square plus c plus ax plus d, if this is there, loss function will tell how good or bad my parameters are, or the machine parameters are. Okay, so this is something it is trying to tell. This is how it will try to tell that, okay, my model is not working good or my model is working fine. So that being said, what some of the loss functions that you're going to study in the whole course will be like square error loss, cross entropy loss, KL divergence. So these are something you will get to know. You will get to mathematical intuition and all. But the gist of the function is, gist of the loss function is, it tells that whatever the parameters has been decided by machine for the particular data, but is how good it is or how bad it is. It will tell that. Okay, so that will come out as a fourth jar of the machine learning element, that or any deep learning machine learning element, that loss function. So I have a data. From that, I will build a task, whatever the task I have. From task, I will build mathematical models to perform that task. To check that whether my task is good or not, I will check loss function. Now, come to the fifth part, which is actually we can say the most important part, or we can say the why this all machine learning is all about. Okay, so we have discussed earlier. Okay, for this problem where my line is actually kind of wavy kind of thing, for this equation of ax cube plus bx square plus cx plus d, for that these parameters are basically a, b and c and d, because x is my input, so that is fine. But I need to find the values of a, b and c and d, which is called as parameters, the parameters which the model is proposing, and loss function is trying to validate that whether the parameters are good or not. So the fifth jar is basically our learning the parameters or the learning algorithm. Okay, so fifth jar is basically a learning algorithm. Okay, that is the fifth jar. So what do you mean by learning algorithm? So learning algorithm is basically the functions, the mathematical functions, which tells that, or which tells the machine how do we identify parameters for the model. Now the model is basically the mathematical function that we are talking about. Okay, it's a mathematical function. Okay, so this is what it's trying to do. Now basically what it's trying to do is it try to find the parameter estimate. It's more like the way the model that has been approximated, the equation of ax cube plus bx square plus cx plus d is there. Similarly, for this equation itself is approximate. For this approximate equation itself, it try to find the values of a, b, c, d and d, so which is called as parameter estimation. Terminology is parameter estimation, which is basically like a search problem. Now why a search problem? Search problem means what is the value of a, b, c, d. And mind you that it is very hard, right, to just give any random variable to a, b, c, d. The reason being they are infinite numbers. Even between 1.1 and 1.2, there will be infinite numbers between these two values. The search space is very high, right? So search problem, it's a big challenge with respect to it. So what we try to do is, make it more helpful to the machine, we try to make something called as, we make this problem as an optimization problem. the optimization problem is how to reduce search space for finding the parameters, that is A, B, C and D, kind of like that. Okay, so it becomes an optimization problem. So again, a learning algorithm is basically a optimization problem. Its optimization problem is trying to identify the parameters in an efficient manner. Efficient manner means it is like less computing. It should take less computation time to for me to allow to reach to this ABCD problem. Okay, so that is what we call as optimization problem. So again, how do you know that whether the ABCD are good or not? That is something we again come back to the loss function. Loss function will say, let's say A, B, C, D. It has first guess was 10, 10, 10, 10 as a random. Let's say it has 10, 10, 10 value. Now loss function will try to say that, okay, what is the value of, what is the final output as a model I'm getting. Okay, so this will be like that. Now after so it will say like, okay, now I have like the difference between this will be like 20% of the actual and predicted value, right? So what I will do, okay, maybe I will reduce the numbers. So I will say now that ABCD is like 2.5, 2.5, 3.5, D might be 4, something like that. Now because of while certain algorithms, I'm not just randomly jumping here, it will be based on certain algorithms that I'm reaching to this value. It will be a lot of iteration, lot of time, it will do guesswork with respect to that. But it will go to a certain direction and say that, okay, because of loss function, my loss is actually giving me only 2 to 3%, which is understandable, which is we can understand that, okay, this much is bearable. So we can say that, okay, this value is giving me much better understanding of the data. Model can understand the data much better way because I have the very less loss I'm getting from this parameter. So I will put this this parameters onto this equation of ax plus b plus c. Okay, now one person asked me that how it is different from a model jar. Okay, the difference from model jar is model will tell you the equation, that's it, right? But the parameters, finding the parameters of this itself is a different kind of algorithm that you have to deal with. Okay, so there's something called as gradient descent. The there's something called as gradient descent. The terminologies are okay for finding the parameters. There's something called as ADA-grad. There's something called as back propagation. There's something called as ADAM. So multiple this algorithms, learning algorithms are there, which tells that, okay, given a mathematical equation, I need to find the proper parameters for those equations. Okay, so parameters I'm saying is A, B, C, D, E. This can be done using these learning algorithms. And why it is called learning algorithms? Suppose I'm starting with 10, to reach to the 2.5, I might take multiple steps to reach to the value of 2.5 for value A, for a parameter A. To do that, how should I know that I should either go up or go down? So that is something learning algorithm is there, which talks about this aspect. And this is very computational, this part is very computational heavy. This whole learning algorithm, actually the whole processing time which we tell with respect to the a machine learning model, they say, oh, I take 2 days, 3 days to learn a machine, to make the machine learn about the data, is all because of this learning algorithm only. And this is actually the core of the whole machine learning problem. So in this case, the the model, the kind of learning algorithm it will choose on top of models will define that what kind of parameter I should have to fit the data. Okay, so again, coming back to the kind of what we have covered till now is we have the data, now we're defining a task. Now once we define the task, we're telling that, okay, which model I should choose or which kind of like whether it's a classification problem, I take it as a classification problem, or as a line equation problem, or as a polynomial problem, or some exponential problem. That is something I want to decide, this model thing. From that, from that model, I will try to define the loss function. Okay. Now from this loss function, these things are decided, model and loss function. I will try to decide the learning algorithm. Now this learning algorithm will assist me to understand whether this model and this loss function is correct for me to understand the data or not. Okay. So it will validate this 1, 2, 3 points for me. Okay, it will validate, learning algorithm will validate model, loss function, and the data. Both these things will be validated by this learning algorithm, and this part will take, this is something only machine can do, we humans can't do, and this is where the machine learning will come into. This whole jar will actually is something learning algorithm talks about the machine learning. The other parts is mostly defined by the humans, but this fifth jar is actually something has been understood by the machine itself, and that's why for us it is very hard to understand that, even though it still it's very hard that, okay, even though the machine has taken the learning algorithm defined by us, how is actually connecting the dots, it is not very clearly explainable by any of the humans as of now. So that is the whole learning algorithm is about. Once we'll go to specific type of problems or perceptron or something like that, you will see that there's a proper algorithm is given for mathematical algorithms given only for perceptron as a learning algorithm. This is because that will act as a core of that. So when we're going to build from any CNN model or any such, that we will talk about more about this learning algorithm for sure. Okay, loss function model you will easy to remember. Learning algorithm itself, what you're going to learn throughout this course. All the mathematics you are going to deal with is basically with this learning algorithm. This is what you're trying to understand. Okay, now the last is the last model, the last jar will be the sixth jar, which basically talks about the evaluation of the model. That is, how do we compute a score for our ML model. Okay, here you might heard the term of accuracy, precision, recall, like that. Now the next natural question we can ask is how it is different from loss function. See, loss function is actually a very granular way, okay, where I am taking one data point, and from that data point I will try to see the predicted data point. Okay, it's more in a granular way that I am taking one thing in the time. It's like you cut a vegetable and you're seeing each and every piece of vegetable whether it has been properly cut or not, right? It takes time and you may not be able to understand it also. For example, loss function value will be 0.2, 0.3 or 0.001. This is something you're not able to understand the performance of the ML model from this loss function. But if I tell you the accuracy of the model is 70%, 80%, 90%, you will say that, you will understand that, okay, out of 10 input in 10 instances that I am giving, out of that 8 instances it is able to predict correctly. That is much better understanding of the ML model as an overall view. So it gives us a overall view of the performance of the machine learning model. Whereas loss function talks about the each and every data point that you're going to deal with. Okay, and this loss function will help the learning algorithm to understand that whether I'm going in a correct direction or not, or when to decide a current parameter value, it should the loss function will say that, okay, the value that you're choosing giving me high loss, change the values. So or you increase the value or you decrease the value. That has been taken care by learning algorithm will take the input from the loss function. But once the model has been trained, so this is during training time. Loss function is basically for training time, but during this evaluation of accuracy, precision, recall, we'll do at the testing time. Okay, this will happen during the testing time. So once the model is ready, I will give certain inputs and it will try to see that whether the output that generated by ML model is correct or not. So just to summarize about accuracy, it just tells about that accuracy is equal to number of correct prediction divided by total number of prediction. Okay, so like that precision has certain value, certain definition, recall has certain thing. We will discuss that over the course of the period of time, because we will be coding, we will code it in the Python, and we will try to understand it in a much better way. Okay, so there's some evaluation metrics are there apart from these three. This is called as evaluation metrics. So it has accuracy, precision, and recall. Right now there's something called as stop key accuracy, there's something called as F1 score, there's something called as AOC score. Okay, so this evaluation metrics will tell us with respect to this. So what is validation? So validation is actually happening during the training time itself. You can do separately as well, but validation is happening that within the training data, while I'm training, I will uh, in between I will try to pass a certain values to that to check that okay whether it's correct or not. So that's how I'm validating it. Or you can see even validation sometimes as evaluation also, but we will discuss that maybe in the next lecture properly. And how to choose learning algorithms. You don't have to choose learning algorithm per se. You will get to know about learning algorithms, you will learn about them, and then you will decide that for an image whether this learning algorithm is there or not. Like there's a set of family of equations or learning algorithms there for images, for text, for speech and audio. Like if you have for image, you can same algorithms you can apply for video as well. So they are predefined existing other which you're going to learn with respect to neural networks that you're going to learn for that. So you don't have to think much about that. What you have to understand that how that learning algorithm actually work, and the all maths which you're going to deal with is about learning algorithms mostly. That how machine is computing, that I should go, I should make this whether the equation or model I'm choosing is a correct or not. And the model I'm using as a terminology is basically a mathematical equation as of now. I'm not telling the trained model kind of like that. So let's for this class, just consider that a model is basically a mathematical equation. Okay. Now to summarize again, uh, since we are almost near to end of the session, uh, the last jar will be the evaluation. So the crux of whole machine framework of whole machine learning problem, or to learn any problem, is basically you get some data, you will know the nature of data, everything you will know. From that you try to define the task that I need to classify the data as a, like suppose images of cat and dog into separate categories, that will be your task. Then you try to define the model with respect to that. For that some mathematical equations will be there. From that you try to define the loss function for that, which can identify loss. There are not many loss functions, there are 4 or 5 loss functions itself, so they are pretty standardized loss function already available. So loss functions are there. You use the loss function to check that whether the model I selected will give me a better, during training time it will give me a better results or not. To do that, to give the better output for the mathematical function, I need to learn the parameters of that function. For that function, the learning algorithm has been decided, and which will support the model and the loss function in deciding that whether the machine, whether I'm learning in the correct way or not. It's more like this, right? If you're trying to learn something new, for example, guitar, if uh, if you just pluck one string, you know that, you might not know because you are a beginner, but someone will say that plucking one string will not help me to learn the guitar. I need to know multiple, how to use multiple strings, right? Someone will give direction. So learning algorithm is like that. It will give direction to the model with the help of loss function, that whether you're learning in a correct way or not. Now once you learn, when the model has been learned, then you will evaluate it using the metrics called accuracy, precision, recall. Again, you don't need to, as of now, as a beginner, you don't need to even select the optimization algorithm also. So whatever the algorithms you're going to learn, the algorithms that we say is basically is what? Is basically is the neural networks. This. So when I say CNN, why it is not working? Yeah, CNN, which is a convolutional neural network. For it is mostly used, predominantly used for images only. Okay, so you don't need, so it has its own learning algorithm. You're going to use that. That's it. that's the thing. In terms of coding, you will just import that function directly. Algorithm will be there. But in this course, you will know that what is actually this learning algorithm for this convolutional neural network, which I can use to understand, to make the machine understand about the images, to make the machine learn about the images that I'm going to give as an input. So, uh, okay, I think my screen sharing has been stopped automatically, but that's fine. We are almost at the end of session. So what we have discussed is very basic, very high overview for the uh, people who are just joining, who doesn't know much mathematical background and all that. Uh, so my most of the session will be mostly like that, catering to that sort of people. So if you are advanced, if you know this, you're free for very free to check other sessions as well. Okay, few more things that which I might skip or I might want you to learn as a precursor is, just a minute, I will start broadcasting again. I want you to learn, or I will to get to know some, get some hands on is, why it's not sharing my screen. Okay, if not sharing, that's fine. So are something called as vector and matrices. You try to learn about vector and matrices. That is the one thing. Another thing, you get understanding with the Python. Maybe in the next session I will give 1 hour. I will just give a brief of Python and matrices. But these are the two important components that you need. Why? Vector and matrices will be the way using which you will give your data to the system. An image will be converted into a matrices, a set of numbers in a certain format. A speech will be converted into numbers, will be put in terms of vectors. So that is a mode of representation of for the system to understand. So these two concepts, Python and vector matrices, this is something you should get pretty good by the time you end this course, because otherwise you will not understand any of the learning algorithms. Because if you don't even know that how you're giving inputs as a data to the machine, you will not able to understand the other aspect as well. So we will try to cover that in the next session as well. Okay. Another thing is uh, how generative fall under unsupervised learning. Uh, okay, generative AI comes under supervised learning is because the output that you're going to generate is not something you have predefined. Okay, so one way of telling this is, so you have seen the Mid Journey, or if you have used Mid Journey as it's a very famous website, you give the description like MS Dhoni in a Sadhu avatar, and it will generate the MS Dhoni as a Sadhu avatar properly. And you have not given that input any point of time in your time, because MS Dhoni is not a Sadhu, right? So how it is generating that, this thing? When you talk about supervised, it's all about that the output is known to the machine learning earlier, and try to map the output to the input. But in the unsupervised, you don't know the output, so you can generate output out of your own wish. Like it's like our imagination, right? We don't know imagination, like it is not coming directly on its own. It is coming, no, it's not coming with predefined, it's coming out of its nowhere, right? It's not defined, we are not restricting it. Similarly, generative AI falls under supervised learning because we don't know the output, and it generates the output on its own. Think it as like a imagination of a machine. Okay, this basically connecting 2 3 dots. Okay, one more thing, I think you want people to know that how to uh, okay, this, I will say entire screen, how to see this thing, right? The live session for any of this thing. So let me try to share this thing. Okay, you can, I hope you can see the screen, and you go to Swayam. Okay, my courses, go to course. Okay, so in this, you might have obviously seen this kind of thing. If we have any specific questions and all with respect to the assignments and all, you can ask the question here. And mostly the TAs of this assignment, which are not taking the live sessions, they will try their best to answer your this to you. Okay, try to answer in this forum. Ask a question. For live session, if you can see the left hand side of the screen where the course outline is there, the top bottom this is a live session, and uh, right now it is not there. Maybe it will come right now. It is showing old, but it will show new as well. So give some time to NPTEL, and it will upload this one sheet will be there. From that sheet you can directly access the all our session. So it will give, so give maybe a day or two. I will also ask NPTEL to give that sheet. There will be a Google sheet where we are giving the YouTube link and all the stuff. Okay, so I haven't created a YouTube channel or a YouTube. I have a channel, but I haven't created the playlist for this. So once I'm after this session, I will stop this recording. I will upload it, and maybe next session I will show. Or by that time, these people, NPTEL people themselves, will show you the recordings of not only this session but the other live interaction session, which has been taken care by other two TAs. Okay. So with that, mm, from my side, this will be the end of the session. Thank you very much. So again, I am keep on repeating this maybe again because some users might get offended. Or they will say it might be a waste of time that I am not solving assignment question as of now because I am more focusing on towards building the basic skills, or at least you should know basic terminologies or basic aspects of that. So I will be covering in the first few sessions. If the assignment questions were there, I will try to cover as soon, but not in the near future. At least for 2-3 weeks, I will be covering basics of Python or vector matrices or the perceptron algorithms and all those stuff. So I will be covering that aspect. So if that sounds useful to you, please free to join this session every Tuesday. So that's the end from my side. If you have any questions, please let me know. Otherwise, I will end this session. Okay, so let me stop the recording and then I will end the session for everyone.